My name is Andrei Anishenko. The topic of the report, corrective function method application for Hurst fractal dimension estimation. My co-authors Oleg Lazorenko, Olena Kovalenko, Marina Udovenko. The term fractal has been proposed by great American physics and mathematics Benoit Mandelbrot in 1975. Following so-called fractal paradigm proposed in 2003 by famous physics professor Janovsky. Fractality was apparent to be one of the fundamental proposals of the world above, as fractality has already become a new paradigm for modern science. There are two types of fractal analysis, normally the monofractal analysis and the multifractal analysis. A fractal dimension is apparent to be one of the most important such numerical. In general, there are a lot of different fractal dimensions which can be estimated as for mathematics as for physical fractal signals and processes. In this paper, we shall deal with only one of such fractal dimension, normally the Hurst dimension, and which only the method for its calculation, normally research range analysis method called frequently as simply RS method. Presented the Rescalate range analysis as one of the oldest monofractal analysis methods to the researchers. He proved the RS method equality with the corrective function method usage, showing the peculiarities, advantages, and discredits of RS method with the results obtained for sunspot number time series analysis as for well-known fractal natural processes. The Hurst exponent being introduced by Hurst in 1951 is apparent to such one older statistical numerical characteristic. In bounds of the general Brown's motion model, the Hurst exponent and fractal dimension, called as a Hurst fractal dimension, are connected with the relation d equals 2 minus h. According to the new fractal analysis method classification introduced in 2022 years, all existing monofractal analysis methods can be divided at 6 different groups. Normally, methods based on the geometric characteristic, method based on the algebraic characteristic, method based on the statistical characteristic, method based on the frequency and time frequency characteristics, complex methods, and special methods. Being statistical by the original RS method is apparent to be a member of the group of the methods based on the statistical characteristics. As well known, the range Rn of the signal is given by relation R dependent n, basing on this value so-called RS statistical is built. RS dependence on the n that way. If a signal investigated has really the self-affine and fractal, of course, properties, all points calculation should be apparent to be grouped around some straight line, being equal to the Engel coefficient of this straight line. The Hurst exponent can be estimated with usage of the last square methods. Based on the results of empirical investigation, Hurst found that the mathematical explanation of such a statistic showed a power law relation with the size of the observation window length ns. The main purpose of the corrective function method is to compensate the existing nonlinear on the function d prime in some way and therefore to increase an accuracy of the fractal dimension estimation obtained with given method of monofractal analysis. To reach this proposal, it was proposed to inverse nonlinear function d prime on the base of so-called corrective function. For each given monofractal analysis method, the corrective function should be built on the described grade over the plane dn with application of the model fractal signal set with no change values of the variables d and n. When the correcting function on the described grid has been obtained, the proposed of the nonlinear function d prime inversion can be started. For fixed n value n equals n signal, the function d prime as a function of one variable on the interval 1 is less than or equal to d and less than 2 can have an inverse function d. Only in this case when the function d prime is monotonic there. In this concert case, the function d prime should be a rising function of d in the interval discussed. Let's condition the nonlinear function d prime graded for the arrest method on the basis of the model monofractal signals. The model is a well-known model based on the modified cosinus Weierstrass model-broad function. And after two examples of such model signals realization with defended fractal dimension d, values are shown at figure 1. It should be pointed that if the consider phi equal constant for all existing n a dimension monofractal signals model, which given fractal dimension d appears as it was pointed above in all the investigation regarding a correcting function building, we used a discrete grade over the plane dn, where d value was changing in 1 is less than d and less than 2 bounds, with the step 0.01, and n value was given by n exactly to the power of k. Normally this way is used now. At the figure 2, a compression of the ideal function 1 d prime is equal to d, and over the nonlinear function d prime is equal to f dn, having fixed n values. 2n equal 32 points, 3n equal 128 points, 4 equal 520, and 5n equal 2048 points are the show. The fact of this function nonlinear existence is well confirmed. Moreover, there are some interesting tendencies. First, for fixed d, the more n value is, the less difference between d prime and d values occurs. Second, in the worst case, the error of the d prime value estimate with RS method usage does not exist, approximate 2.5%. To demonstrate the results of summary application of the RS method and the correcting function method for investigation of a real natural physics process, let's consider well-known the sunspot number times series. The time series of sunspot numbers, which characteristic solar activity and is associated with the point of sunspot, that it has a constant 11 years cycle. Supermost perhaps on another slow company with a period of about 100 years. The fractal dimension was d equal 1.1. These results were obtained using the RS method in a number of later works. Quite similar results were obtained using other methods of fractal analysis in practical d equal 1.2 and 1.3. We believe that such results can be explained by decimation operation, probably in 100 times applied to the time series investigate. but we use this time series without any decimation. Therefore, all high-frequency structure is apparent to be safe. For present analysis, the daily total sunspot number from 1st June 88 till 2024 year were chosen. To show existence of the fractal structure for the signals investigated, we use the continuous wavelet transform. It is important to point that the tree-like structure operate at the time frequency plane can be considered a true structure of a signal fractality. In this case, the debauchy wavelet of the fourth order used, as it had been found by Mandelbrot. The sunspot time series is not monofractal, having there some range of periods where monofractal periods can be described from the fig where the dependence of logarithm Rs we see logarithm n given by this relation in show. Such ranges and corresponding values of Hurst fractal dimension d are defined. It was found that in the range of periods from 7 to 70 days, d equal 1.66 from 3 to 30 months, d equal 1.91 from 30 to 90 months, and from 30 to 200 years, d equal 1.58. In other range where given dependence cannot be useful approximate by a straight line, the sunspot time series is apparent to be non-fractal. If for steering line approximate building one used all points should be at fixed, some advanced Hurst fractal dimension value which is able to characteristic the wall signals investigated can be estimated. This value is found to be 1.78. The conclusions are presented below. The RS analysis method is the oldest and the most popular way to estimate a Hurst exponent for any signals of process. In bounds of the generous Brown motion model, the Hurst fractal dimension and the Hurst exponent are connected with d equal to minus h. Grading of the results of numerical modeling with usage of the corrective function method and the set the model stochastic monofractal signals based on the modified cos-inverse Strasse function Mandelbrot. For RS method, it was found that the dependence between a fractal dimension value d prime estimation and true one fractal dimension d is apparent to be principally non-linear. The main peculiarity of the RS method as the most popular estimation of Hurst fractal dimension were investigated. The corrective function was built at the explain of the monofractal analysis of the sunspot time series. The possibles of the simulation application of the RS and corrective function method are shown. Thank you for your attention.